Lisa was invited by an old student friend to spend Christmas on the west coast of Sweden. Her nephew, Otto Robert Frisch, who was also a physicist, came to join her there.
Aunt? 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 Lisa, how are you, my dear? Merry Christmas, Aunt.
I need your help. Come on, let's go out.
But I was hoping you'd help me.
Back in Berlin, Hahn was getting strange results. He found no evidence to suggest that bombarding the uranium nucleus with neutrons had caused it to increase in size. In fact, his experiments seemed to be contaminated with radium, a smaller atom. He desperately needed Meitner's expert analysis. From afar, she was starting to suspect that something very different was happening in their experiment.
Hahn and Strassmann are getting some strange results with the uranium work.
Really?
A couple of months ago, Hahn told me that they were finding radium amongst the uranium products. We are looking for a much bigger element, and here we're finding something much smaller. I urged Hahn to check again. It couldn't be radium. And now he writes to me and tells me that it's not radium, it's barium.
That's even smaller.
Exactly. Hahn is sure that it's another error, but I don't know anymore. It is at least possible that barium is being produced.
So Hahn still needs you to interpret the data.
It is my work too, you know.
Exactly.
Well, I can't be there, can I? Come on, let's walk.
Surely he's made a mistake, hasn't he? He hasn't done what you told him to.
Oh, my darling Robert, he may not be a brilliant theorist, but he's too good a chemist to get this wrong.
If you imagine a drop of water, a big drop, it's unstable, on the verge of breaking apart. It turns out that a big nucleus like uranium is just like that. Now, for 4 years, Meitner and Hahn and all other physicists had thought that if you pump more neutrons into this nucleus, it'll just get bigger and heavier. But suddenly, Meitner and Frisch, out in the midday snow, realized that this nucleus might just get so big that it would split in two.
If the nucleus is so big that it has trouble staying together, then couldn't just a little tiny jog from a neutron...
Yes, but if the nucleus did split, the two halves would fly apart with a huge amount of energy. Where's that energy going to come from?
How much energy?
Well, we worked out that the mutual repulsion between two nuclei would generate about 200 million electron volts. But something has to supply that energy.
Wait, let me do a packing friction calculation. The two nuclei are lighter than the original nucleus of the uranium by about 1/5 of a proton in mass.
What? So some mass has been lost. Einstein's E equals mc squared.
If we multiply the lost mass by the speed of light squared, we get 200 million electron volts. He split the atom.
No. You've split the atom.